AP Cram, Calculus, AB, Section 1 Exam Review. Question 7, Relative Maxima. For what value of k will x plus k over x have a relative maximum at x equals -2? Is it A, -4, B, -2, C, 2, D, 4, or E, none of these? In an effort to figure out whether or not there is a relative maximum at x equals -2, we have to take the derivative of the function. And the function is f of x equals x plus k over x. Therefore, we're taking the derivative with respect to x of k over x plus x. What we'll do is factor out the constant k, and the next thing that we're going to do is differentiate the sum term by term. Okay, so the first term comes from the fraction d dx of 1 over x, and the second term is x. So we're taking the derivative with respect to x of x. Now we're going to use the power rule. This is the power rule right here. That says d dx of x to the n is equivalent to n, which is the exponent, times x raised to the n minus 1. And in this case, since n is equivalent to -1 for the first term, d dx of 1 over x equals d dx of x to the -1, which is equivalent to -1 x to the -2 power. Okay. So the expression can be plugged into the original equation. So we now have d dx of x plus -1 over x squared times k. And the derivative of x is 1, so we're also going to plug that in. And in order for the first derivative to be equivalent to 0, we find out that k has to be equivalent to 4. All right, so now for the moment of truth. We know that this is our first derivative. If we take the derivative of the first derivative, that's going to give us the second derivative. And now we can perform the second derivative test to determine whether or not we have a local maximum. So we're going to take the derivative of 1 minus k over x squared. Now the derivative with respect to x of 1 is just going to be 0 because that's a constant. Okay. Now we factored out our constants. As you can see here, we're differentiating term by term, and we're factoring out the constant k. So now if we analyze what's within the parentheses, we're going to be taking the derivative with respect to x of 1 over x squared. And we're also going to factor out the negative sign. So we factored out the k and a negative sign. So now we're taking the derivative with respect to x of 1 over x squared, or the derivative with respect to x of x to the -2 power. Use the power rule that d dx of x to the n power is equivalent to n times x to the n minus 1 power. Okay? So in our scenario where n is equivalent to -2, that's because you have x squared in the denominator. The denominator position negates the exponent. Therefore, we have the derivative with respect to x of 1 over x squared is equivalent to d dx of x to the -2 power which is going to give you n. That's negative 2 times x raised to the negative 3. And that's our n minus 1 in this scenario. With some rearrangement, we get that our second derivative is going to be negative minus negative 2 over x to the third power. Now, if we were to plug in negative 2, we would find out that our second derivative is greater than 0 for a value of k equals 4. So let's just do that really quickly. So we have negative 2 divided by a minus negative 2 divided by negative 2 to the third power times 4. So negative 2 divided by negative 8 is going to give us 1/4. And that's a negative 1/4 if we factor in this minus sign right here. And then negative 1/4 times 4 is going to be equal to negative 1. So negative 1 is definitely less than 0. And the second derivative rule says f does have a relative maxima at x is equivalent to negative 2 because the value of the second derivative there is less than 0, okay, for k equals 4. Therefore, the correct answer would be D4. Okay.